All right, so the recorder is started, and I'm just gonna wait another 10 seconds or so for the rest of the class to show up. We got 6 people right now, so we are missing about 75% ish of the class. All right, well, it is 9 o'clock. I am going to get started. All right, so after Monday's discussion, hopefully you have watched the video from Monday. So, what do you think of AI and how that's going to change the way that you prepare for your future? Any ideas? No concerns whatsoever? Yes, go ahead. Oh, no. All right. Well, I'm just going to say that the landscape is changing really rapidly. It is not like there are no jobs, okay? There are jobs out there. The AWS, the Amazon AWS people who made a presentation that I attended like a few weeks ago, they said there are jobs. They were having problems finding the right people for those jobs. And you might be thinking they're looking for, advanced or senior engineers. They're not. They're really looking for entry level employees, but only with the right skill set. And the right skill set is okay. So this is my perspective. He didn't quite say that, but I think they need people who can write code by hand. Okay, so that means that without any AI tool, they want people still be able to write everything by hand. So that's requirement number one. Requirement number two is with the availability of AI tools, they also want the same people to identify which part can be done by AI and speed up the process. So that's the kind of people they're looking for, which basically means you still have to understand everything that you are learning through college, but on top of that, you also need to know, how to utilize AI in an effective way. So how do you practice? Okay, so this is unrelated to this class. How do you practice AI without using AI to do your homework throughout your entire experience here at ARC and also after your transfer to a 4-year university? Does everybody understand the question itself? Because you need some experience working with AI, using AI to help you code, but at the same time, you don't want to use AI to do your homework. So that seems like a contradiction, but it's not. So the question is, how do you navigate around these two seemingly contradictory objectives? Hmm? Use AI to help you study. That's a good way to use AI too, because when you use AI to study, you are learning how to prompt the AI. So instead of giving me the straight up answer to some question, you can prompt AI to help assess which part of the concepts you already understand, and then build on top of what you already understand. So that is really important. But there's one more thing. Okay, take on some side projects. Okay, whatever your hobby may be. Okay, let's just say that you are a cycling, you know, fanatic. Okay, you just want to ride your bicycle from one place to another place. That's kind of your hobby. Or you like fishing. Okay, or you like gardening. Okay, turn those things into projects. Do some coding projects with whatever your hobby is, and then use AI in that process. And then you also want to use GitHub so that you have a log of all of those projects with the correct timeline. Because all of that is going to be able to show the potential employer or at least your interviewer that you have, take on some additional projects other than your homework assignment. And you can use AI all you want with these projects without impacting what you're really learning in your classes. So I think that's actually a good thing. And then one more item is to take on internships. Okay, it doesn't matter whether the internship is just IT support, which is fairly easy for people who are in a programming track. take on those jobs anyway. Okay, because you might spend one single semester, acting as an IT support person at a four-year university, and then the second semester that might be opening, for you to become a developer. So, do not underestimate the importance of internship, even if the job title seems to be like, ugh, this is not what I want to do. Well, if you don't have a choice, take it anyway, okay? Because you don't know where it is going to take you. All right, so it doesn't seem like there is a whole lot of interest in these topics. Then we are going to move on to the final exam. Okay, so the final exam is going to be on the 15th of December, starting at 8 a.m. Okay, so that's what we figure out on Monday. So you probably want to mark it on the calendar so you don't forget. And then the second one is I have posted the final exam from spring 2025. I will talk about it next Monday. Okay. So if you want to be more interactive, you want to ask questions about the final exam from spring 25, you're more than welcome to be here, okay, in the classroom, because I'll be talking about it here in the classroom. Typically, I have 2 to 3 people who are actually in the classroom. So that's why the discussion usually go really fast because I don't have a whole lot of questions from the rest of the class. But I think it is important to understand what this final exam is like. And your final is not going to be exactly the same because this semester we actually covered structures, whereas last semester I did not cover structures. So your scope is actually a little bit bigger compared to last semester. And I am not going to take a look at the final exam right now because I got some other stuff that I need to talk about. But when you have time, okay, before next Monday, I highly recommend that you take a look at the final exam because you should be able to take it on already, okay? Because the final exam from last semester did not involve the use of structures at all. Okay, so we have covered all the topics, so you should be able to take on the final exam even as it is now. Okay, so do it before next Monday if you want to be here live so that we can talk about, what you struggle with, where you're getting stuck with, and we can kind of move on from that. So the final exam from last semester is not something that you have experienced in your exam one nor exam two. So it's a kind of new format to you, and you might want to take a look, think about it, and derive some strategies of how to deal with those questions. So that's a topic for next Monday. And what we'll do today is I will try to see if there are any interest in looking at the solution of the homework assignment. So do we have any questions or any interest, or should we move on to talk about sorting? So I see nods. So for the homework, okay. So we can talk about the homework. Okay. So let me go to the homework. And you have a new homework assignment called Structure and Parameters. So that's due next Wednesday. So you have another homework, and I don't think it's going to take you that much time, but I'm giving you a whole week to work on it. All right. So we are going back to the homework assignment that was due today, which is by reference and value. Okay, so I'm clicking on it. This is the program. Okay, let me go back to the original Zoom level. So this is the actual code of the program. So I'm going to copy and paste it into the text editor just to give it some line numbers. And then we'll take some snapshots. There we go. Paste. And then we'll take a snapshot of this so that we get the line numbers. Okay, there we go. And let's see. I think I'm just going to clipboard it, put it into the document that I have prepared for today, which is this one. So I'm going to paste it here, and then we'll go ahead and trace the algorithm. So before I do this, are there any questions, general questions about the concepts involved in this particular homework assignment? Yes. Well, how do you know whether it is passed by reference or passed by value? The ampersand. Yep. So yeah, go ahead. So when you pass by reference, the parameter itself is still taking up one more column when you look at the spreadsheet, but that column does not contain the value of the parameter. It contains a reference back to where you're supposed to find the value. So it doesn't save you memory, at least in the case of an integer, because the size of an integer is about the same size as a reference. So whether you pass by value or whether you pass by reference, it doesn't save any memory, but it changes the way that you access the value that you need to work with. Okay, so that's a good question. As we trace through this, by the time we get to line 12, I hope it will be clear, and it will be able to answer your question. Okay. All right, so I'm going to start the trace here. Okay, we have comments. In this case, it's not going to be used at all because we don't have any conditions to evaluate. And then we have a line number, which is tracking at which point of the program are we executing. And we'll go ahead and start with the precondition. Nothing to talk about. There are no global variables of any kind. So we only have local variables. And what I'll do is I'm going to combine line 6 all the way to line 9 because there's otherwise the trace just gets unnecessarily long. You don't have to combine, but I'm going to do the combination just so that I can save a few lines here. So we're going to allocate columns for local variable v, local variable w, and local variable z. So all of these are unknown to begin with, so they all have question marks. So now we get to line 10. V is initialized to a value of 20. We get to line 11. W is initialized to a value of 5. And then we get to line 12. So I'm just going to pause at this point and see if there are any questions. No questions at this point. All right, so we are now on line 12. Okay, so when you're on line 12, you have to figure out the dependencies, okay? In other words, what do we want to do ultimately, okay? So ultimately, this is an assignment statement, which means we want to evaluate whatever is on the right-hand side of the single equal sign, and then we change the value of whatever is on the left-hand side to the value of the right-hand side. So are we okay with that concept? Because the concept of an assignment statement or assignment expression turned into a statement because of the semicolon was discussed really early in the semester. So the question now is, how do we evaluate the right-hand side? The right-hand side is a function call, okay, and the function does return the value. So that means we have to first call the function, which is called compound add. So that's what we need to do first, okay? So to call a function that returns a value, and we have some additional stuff to do when we get back onto line 12, we have to use return info. Oh, I just typed the key when it's at the wrong spot. That's okay. And where? Oh, okay, there we go. All right, so we need return info here. And the return info is going to help me remember where I need to go back to, which is line 12. And what else do we have to do on line 12, which is really just the assignment operation. The right-hand side involving the call to compound add is replaced by a single question mark as a placeholder. And that's the only thing I need to write in the column of representing the return info. And then we have to set up the two parameters. So the name of the parameters depend on the definition of the function. So in this case, the name of the first parameter is x. The name of the second parameter is y. So now we have to look at the two parameters. One of them is passed by reference because of the use of the ampersand symbol, and the other one is not. So if it is not passed by reference, it is passed by value because in C++ and also in most other programming languages, you only have two ways of passing a parameter. It's either passed by reference, which in this case is x, or it is passed by value, which in this case is y. Are we okay so far with understanding symbolically how do we can tell whether a parameter is passed by value versus passed by reference? We good? Okay. So we'll work with y first because it's easy, okay? Because it's passed by value. If it is passed by value, then the argument, which is w here, is treated as a general expression. Okay, you might as well just call this w plus 1 in parentheses and then the whole thing divided by 1 because it doesn't matter. Okay, it is just an expression. So when we evaluate the expression w, we look up the rightmost column that is labeled w, which is column D. Column D has a value of 5. So as a result, the second argument is just going to be 5, which is used to provide an initial value for the pass by value parameter called y. Okay, so that's why we put a 5 here. So now we get back to x, which is a little bit more complicated because x is passed by reference, which means whatever we use to pass to parameter x, it should specify a column of some kind. And we can see that argument v, which is our first argument, specifies a column. Because when you look up the rightmost column that is labeled v, it is column C. Okay, so it is a column specification, and that column specification is passed along to parameter x. So parameter x is a reference to column C. So I'm going to pause here because this part is really crucial. We have talked about this several times in this class, but it is important to understand what is passed by reference versus what is passed by value. So I'll be comfortable with those two different concepts of passing a parameter. So we're good. Okay. All right. Yes, question? Oh, you're just confirming. Okay. Very good. So now we continue execution at the function that we have called. Line one really doesn't do a single thing. So typically, except for this class, I typically do not even track, line one because there's nothing to do on line one. So we move on to line two. When we analyze line two, we recognize that it is an assignment statement, which means we evaluate the right-hand side first. The right-hand side says, I need to know the value of x. So you look up the rightmost column that is labeled X, which is column G. Column G says, oh, don't look at me. I don't have a value, but I can tell you who has the value. It tells you to go take a look at column C. Column C says, yep, I have a value of 20. So that's how X on the right hand side evaluates to 20. This Y over here, same thing. You look up the rightmost column that is labeled Y. The rightmost column that is labeled Y is column H, and it has its value, which is a 5. So you have 20 plus 5, which is 25. That's the right-hand side of the assignment on line 2. What are you going to do with a 25? Well, we have to use 25 to update whatever is on the left-hand side of the single equal symbol, and which is X. So you go like, hey, X, who has the column of X? The rightmost column that is labeled X is column G, but column G says, don't change me, because I can tell you which column you're supposed to change, but don't change me. Do not change column G. Instead, go change column C. So that's why column C is the one that is updated to a value of 25. So can I answer your question? Do you guys have a question for me? Nope. Okay. All right. So that's why we update column C instead of column G. Okay. That is the whole purpose of pass by reference. It allows a function or subroutine to change something that does not belong to it. Is that okay? So understanding the main concept and the purpose of passing by reference is important. Yes. Yes. Mm-hmm. Yep. Mm-hmm. So now we move on to line 3. So line 3 is returning x. So now we do the same exercise. We look at x, which is a reference of column C. which now has a value of 25. So that means 25 is the return value. As we execute line 3, which is basically return 25 now, we do the usual thing of executing a return statement, which is look up the rightmost return info cell, which is column F. We copy and paste it, and the only thing you need to change would be the question mark. You change the question mark to whatever value we are returning, which in this case is 25. So now line 12 looks like this. And then we skip one row to the next row over here to repeat what we have just figured out. Because this helps to remind us what to do when we get back to line 12. And then after that, the 3 columns that we allocated for the invocation of compound add they are no longer needed. So they are basically deallocated or struck out, in terms of the font here. And now we are getting back to line 12. Line 12 can now execute because now we have resolved both the right hand side, so and also well the left hand side we can resolve now. So we need to change the column that is labeled Z with a value of 25, and that would be column E. Column E is now changed to 25, and that way after that we get to line 13, which is a return 0, and for the purposes of this class, that is the end of the execution. So this is the full trace of this particular algorithm. And you can see that it's not super duper long. It is not crazy like the Fibonacci program. I know that one is a little bit long, right? This one is not long at all, okay? But it does have some tricky parts to it. Um, so do we have any questions about this? No questions about this? The grading of this home for this particular trace really is based on when we execute line 2. This one row here is the basically what I will be using to evaluate whether you get how many points you're getting, because that's the whole point of passing by reference. Are we doing okay so far with this? Okay. Because all of the other concepts, like how to call a function, how to set up return info cell, all of those were covered before. Fibonacci more than sufficiently test your knowledge of calling a function and returning a value. Okay. So the main purpose of this particular program is basically row 10 of the trace. Do you know what to update on line 2? That really is the question. Are we doing okay so far with this? All right. Okay. So I'm going to call this sheet assignment key or answer, whatever you want to call that. All right. So now that we have talked about this, we can now move on to talk about sorting. Okay. So we'll start a new tab here, sorting. Okay. So if I give you a deck of cards with numbers on each card, and they are kind of randomized, okay, how do you do the sorting? That's my question. Okay. Okay, first of all, do we understand what sorting means? Okay, we have some nods. Okay, does everybody know what sorting means in the context of this class? Make things so that they're in order. Okay, so I can give you an example. Okay, so this is not even an array. I'm just giving you a list of numbers. Okay, so I would just kind of randomly pick some number, 56, 13, 45, a 2, and then followed by a 0. Okay, and if I want everything to be in a non-decreasing order, which is not exactly the same as an increasing order because things can be the same, well, I might as well throw in something that is the same so that we can illustrate that point. So if I want everything to be in a non-decreasing order, what would that look like with the same 5 numbers? Okay, if I after sorting, it would be 0 goes first, and then a 2, and then a 13, another 13, and then a 45, and then 56. Okay, so that's what sorting means. Okay, so sorting means we want to reorganize something in a list, or we can call it an array, call it a vector. There are many names to call these things, but we want things to be in order. Okay. And typically in a sorting algorithm, if it doesn't say anything, it is in a non-increasing order, excuse me, non-decreasing order, which is what we are seeing here. So are we good so far? So now the question is, how do you derive an algorithm to do just that? So now you have to think about, if I give you a huge deck of cards with numbers on it, how do you sort those cards manually? Okay, so you guys can share your insight. Okay, if your life depends on it, how would you do it? Let's just say that you have 200 cards. You cannot just eyeball. Yep. Okay. Yep. Yep, exactly. Okay, so that's what we call the selection sort algorithm, which is the most intuitive algorithm for sorting. There are many algorithms for sorting, but this is the most intuitive one because we can do it fairly easily. Okay, so what that means is, instead of doing everything in one single stage using what we call in computer science the eyeball algorithm, which is basically saying I just look at the numbers and I know how they're supposed to be ordered. If you do it systematically, we basically identify that, oh, look at this. This is the smallest of the entire thing. So we're going to move it all the way to the beginning. Okay. So that means, the first stage, okay, is going to be like this. But if you move this all the way to the beginning, what is going to take this place? Ooh, how about this? We just exchange these two. In other words, the 0 goes here, and then the 56 goes here. So that's basically, how we do it. Okay. So now the array or the list looks like this, and I'm going to highlight, those two so that we can understand how, what occurred. Okay. So we have these two, and then we got these two. They are exchanged in position. Are we doing okay? All right. So now we look at this list here, and we don't have to worry about this anymore because it's already known to be the smallest item. So that means at this point, my focus is going to be on the rest of the array of those four items. Does it make sense? Okay. So what I'll also do is I'm going to use some formatting thing to help us understand, what we are looking at. So for the first row, we have to look at the entire thing. Okay. All six items must be examined because we really have no idea who is the smallest. But once we have found a smallest item, okay, which means it may not be the only smallest item, and we put it all the way here, that means this position is already settled. Okay, it is already the right item at the right position. So now our focus is shifting to the remaining four items, and I'm going to use another thing here to specify what we're focusing on. So of the remaining five items, okay, 13, 45, 2, 56, and 13, which one is the smallest? The 2. Very good. Okay. So what we'll do is like, oh, okay, this one we can just duplicate. Okay, this one just kind of goes here. Okay, and we can delete the formatting. But this one is becoming the smallest among the remaining five items. So the 2 is going to go here. The 13, which took the place of the 2, is going to be exchanged with the position of the 2. So this way, we don't have to allocate some additional space. So I'm going to change the highlighting a little bit. So these two are exchanged in terms of position, and then these two are also exchanged in position. So we're going to use, just slightly different shading, colors, and whatnot. And then the other items are remaining as is. Okay, no, nothing changed, between those remaining three items. Are we good so far? With the third row of the process? Okay. So at this point, we know that this item and also this item, they are already the right value at the right position. So that means, my concern would only be the remaining four items. Does that make sense? Okay. So now we put a rectangle around those remaining four items, and so that we focus on just those four items. So of the remaining four items, which is 45, 13, 56, and 13, which one is the smallest? One of the 13s, right? So we typically just go for the first one. There's no need to go for the second one. So we just typically look at the first 13 and go like, okay, it doesn't belong here. It really belongs here. So now we go like, okay, 13, how about you go here? And the 45, you go take the place that the 13 was. Okay, so these two just exchange their position. Okay, the rest of the array stays exactly the same. Okay, so this time I'm going to have to choose the same color because otherwise I cannot represent what is going on here. But between these two, I can recycle some of the earlier colors. Okay, maybe not. Okay, just these two. Are we good so far? So by the time we are done with the fourth row, okay, or row four over here, we have already fixed the positions of the first three items. So that means I only have three additional items to work on. Okay, so put another rectangle over this. Okay, so now my focus is only on these three items. So we have one, two, and three. Which one is the smallest? The 13, right? So the 13 really should be here. The 45 can be exchanged with the 13. So that's why, in the next row, the 13 goes here. The 45 is going to go here. The 56 remains as is. And everybody else stays exactly the same. So I'm just going to put all of these here because once they are settled, they just remain in their current position. So now we use the color coding again. Okay, so 45 is now changed to here, and we use this pale yellow color. The 13 is now exchanged from here to here. And once again, we can recycle some of the earlier colors because there's no conflict. There we go. And now we only have two items left. Okay, so we're going to put a rectangle over those two items that we're concerned about. And everybody else can stay exactly the same as they were. So between those two items, we can see the 45 is the smaller one, and it has to exchange with the 56. So now the 45 goes here, the 56 goes here. So I'm going to use the same color scheme just to make sure that we highlight what is going on for each row. I think it's this color here. Yep, or not. Nope, it is not. It is the lighter shade of yellow here. There we go. And in between these two, I can use some of the earlier colors. Yeah, maybe the bright yellow color over here. So technically speaking, we have one more item left, okay? Because we have fixed the positions of everybody else except for the 56. So technically speaking, I should put a rectangle over the 56 and ask, hey, out of this one item here, who's the smallest? What do you think is the answer to that question? If there's only one item left, it is by default the smallest. So that means I'm actually done. Okay, there's no more step to perform because the 56 has to be in the right place because everybody else are already in the right places. So whatever is left must be in the right place too. Is that okay? Is that logic doing okay? Hmm? The algorithm does not know it, so we know it so that we can write the algorithm so that we can terminate the algorithm at this point. All right. So are we doing okay so far with the concept of selection sort? We're doing okay. All right. So I'll do one thing. Okay. So let me change the speaker output so it doesn't play on my Bluetooth, and instead it is played on my computer. There we go. And turn it on like that. And I'm going to pause the recording, not stopping. It's going to be a pause because I want to show you something that is to do it. Okay, so the recording is resumed. Okay, so there are many illustrations of these sorting algorithms. Okay, this one is by dancing, but if you just look up online, okay, animation selection sort, it will give you like tons of material. Okay, so to help you intuitively understand how to get this to work. All right. So our focus now is shifting to, okay, if this is what we need to do, how do we specify the algorithm to do it? Okay. So when you look at something like this, out of the control structures that we are talking about, which ones come to your mind? So let's see, how many different types of statements have we talked about in this class? We started off with the assignment statement, right? And then we talked about conditional statements, and then we talked about the block statement, and then we talked about the while statement, the loops, the two loops. One is do while, the other one is just while. Um, and that's it. Those are the only control structures that we have talked about. So the question is, let's focus on just one row at a time, okay? So we're going to look at row number 2, and we want to ask, how do we figure out that this is the smallest value of the 6 over here so that we can exchange it with whatever was taking its place? So what would that be? What would be the answer be in terms of how do we figure out which one out of the 6 numbers that it has the smallest value? So that's our focus, okay? So let's solve that problem first, okay? Is to find the index of items, of a item in the array that has the smallest value. That's all we want to do for now. Does that make sense? That we are breaking down the bigger problem into a smaller one, which is really just focusing on, I just need to find out which one has the smallest value, and then we'll decide what to do with it later. All right? So we are going to go write an algorithm just like that. Okay. So I'm going to switch to that will work. Okay. So we'll switch to the notepad here, or we can switch to the command line. Either way, it doesn't matter which way. Okay, I'll use the command line just because I'm used to NVim a little bit better compared to mousepad. Okay, so we'll just say this is find min, but we are also finding the index of the minimum item. Okay, so we are not just finding minimum, but we are finding the minimum index, which means we are looking at the index of the item in an array that has one of the smallest value. Okay, all right, so we're gonna go here, and this time I'm going to start with main. Okay, because I want to illustrate what we're given with, and then we'll talk about how to deal with the rest. So we're going to start with an array of integers. We'll call those numbers. Okay, not very inventive here. So this is an array of integers, and these are the values. And I'm going to use exactly the same values as in the example, which I cannot remember, but I can do this. All right, so we're going to have 56, 13, 45, 2, 0, and then 13 again. All right, so now I can put this back onto the main area like that. And I also need to know the number of integers in numbers. And I think we might have talked about this already. So I have n being initialized to be the size of numbers divided by the size of numbers bracket 0. All right, so let's focus on line 3 and just to figure out what it is doing. Size of, in parentheses, something, is really asking the question, how many bytes? Okay, it's a unit of memory allocation. So it's asking how many bytes are used in the array called numbers. And then we are dividing that by the size of the first element of numbers. So that will give us the number of items in the array numbers. Does everybody understand what that means? Yes. The second part? Okay, so inside the parentheses here, this is specifying the first item of numbers, which is an integer. Now, how big is an integer, or how many bytes does an integer take? That's kind of variable. Okay, it can be 2 bytes in some platform, on some platforms, 4 bytes in some platforms, or up to 8 bytes in some other platforms. I don't want to have to deal with figuring out that myself, so I'm just asking the compiler to help me figure that out. Okay, and we're going to go do a return 0 here, and then we want to specify the actual algorithm, right? So the actual algorithm has to go through every single one of these, and it has to keep track of the index of the smallest item. So right away, I know that I need to keep track of min index, okay? But I'm not going to do it in main. I would do it inside. Well, do I want to do it in main? No, let's do it in main first, okay? So I know that I have to keep track of a min index, okay? And I will also comment what this means, okay? This is the index of the smallest item, okay? And then we also have to keep track of which item we are actually looking at, okay? Which I'm going to use I for. So I is going to be index of the item to compare to the smallest item, okay? So now I need to do some initialization. So mean index is in this case initialized to a 0, okay, just to begin with. So I'm assuming the first item is the smallest, okay, but that's an assumption. And then I'm going to say I equals to 1, which means, hey, there's no need to compare an item with itself to see whether it is smaller than itself. That's just a waste of time. So the item that I'm going to compare element 0 to is going to be the first one is going to be element 1. And then I use a loop, okay, to basically say, as long as I have not seen everything in the entire array, I'm not done yet. So I'm going to say, as long as I is less than n, I got stuff to do, okay? Because I is less than n means I have not looked at every single item yet. So the next item might be the smallest item. So I still need to look at that. But every time I go through this loop here, I has to be incremented by 1 because I'll be looking at this at the same item over and over again. So now I go back here and I say, okay, if numbers bracket mean index, okay, which is the index of the smallest item up to this point, if that turns out to be actually greater than numbers bracket I, which is the number that I'm examining right now, if that is the case, it means, oh, that min index that I have before is not actually the min index. So I have to change the min index to I in this case. Min index equals I, like so. And by the time we exit the loop, I should have found the index of the smallest item in the entire array. Okay, so are we okay with the logic of the code? Okay, just understanding it, not from the deriving it perspective. So we're good or not? I will run the algorithm in the trace. Okay, so hopefully that will also illustrate how this algorithm works. Okay, so we'll just go ahead and let the compiler work this out first, and then we'll take a look at the how we trace it. So we go G plus plus is going to work, and so the other one would do too. So find index, and I need to supply the executable. Without the dash O, it will still give me an output called a.out, gdb a.out. And what we'll do is we're going to go to line 14 and run the program, and then we want to print what is mean index. It says it's 4, okay? So the question is element 4 actually the smallest item of the entire array at this point? What do you think? Well, let's take a look. This is index 0, element 0. This is element 0, element 1, element 2, element 3. Aha, element 4. So the algorithm works correctly, or at least it appears to work correctly here. So once you know that the algorithm seems to be working correctly, let's trace it, okay? Let's do it line by line so that we understand how it works, okay? So that's going to be the next tab. So next tab here is the trace of finding the minimum index for the entire array. So at some point we are not going to take a look at the entire array, and instead we'll only be looking at a portion of the array. But for now, this is okay. So we'll go ahead and let me see what I want to do here. I can go back and look at the source file and then just take a snapshot of this, but I want to change the font size first so it doesn't take up too much space. All right, so we copy to the clipboard. I think that should be okay. All right, and then we just paste it somewhere around here. There we go. And then we'll run this algorithm. So we do need comments in this case, and we need line number. We won't be using a whole lot of columns. We won't be dynamically moving things around, but this is a good starting point. Precondition is nothing. There's nothing to say. This is line 1. And then line 2 is going to allocate for the entire array numbers. So there are 6 items in numbers. The element 0, element 1, element 2, element 3, element 4, and then finally element 5. And I'm going to shrink the size of the columns a little bit just so that we can see the algorithm itself and also the elements. All right. So all of these, I'm going to combine all of these. Okay, go to Format, go to Merge Cells, and basically all 6 columns here are corresponding to numbers. Are we good so far? And they have initialized values, which means we already know the first item has a value of 56, 13, 45, 2, 0, and also 13 here. So that's what line 2 is doing. Line 3, not a whole lot of work to do. We are just creating another local variable called n, which in this case is just knowing how many items are in the array, which is 6. Okay, that is not going to change over time, so we are not too concerned about this column. Line 4 is allocating a new column called min index. It starts with an unknown value, and it will be used later on, and we'll be updating it later. And then finally, we have column number 5, line 5, which is allocating another column called I. It is also unknown to begin with. Like so. Okay. Any questions up to this point? Okay, no questions. All right. So we are going to move on to the initialization of mean index and also I. So we go to line 6, mean index initializes to a value of 0. And then line 7 initializes I to a value of 1. So once again, the significance here is I'm assuming element 0 is the smallest of the entire array because I haven't looked at anything yet, right? So the only thing I can say is I really don't know who is the smallest, but since you're the first one, I'm going to make the assumption that you are the smallest until I find somebody who's smaller than you. And then I start with 1 because there's no point in comparing element 0 with element 0 because element 0 is not going to be less than element 0. So there's no way I can start with I equals to 0, but it's not going to be helpful. Okay, so I'm going to say, okay, how about we try to compare element 0, which by assumption is the smallest item, to the item that is right next to it. Okay, so that's why I is initialized to 1. And then we get to line 8, which has a condition to evaluate. I is less than n is true. So we go to line 9. Line 9 is asking, okay, I'm going to use n instead of numbers just to save some space here. So it's asking n numbers mean index. I'm use mi here because otherwise it just takes up a lot of space. Is greater than n bracket I. Okay. So which 2 elements are we comparing? Min index is 0 at this point. I is 1 at this point. So I'm comparing element 0, which has a value of 56, to element 1, which has a value of 13. Is 56 greater than 13? Yes. Okay. So now we say, yep, the answer is true. So we go to the then portion of the conditional statement, which is on line 10. Line 10 doesn't really do much. All it wants to do is to copy the value of I, which is 1, to mean index. So mean index is now 1. In other words, between element 0 and element 1 is the smaller one. Is that okay? That's why we have the update on line 10. And then we get to line 14, line 12, sorry. So we get to line 12, I is incremented to 2, which basically is saying, okay, now that we have settled, okay, from element 0 to 1, the element 1 is the smaller one. Let's take a look at element 2 next, okay, to see if that is also smaller than element 1, okay? So that's what we are doing here. And we go back to the beginning of the loop, which is on line 8, okay? And then we ask, is I less than n? Well, I is 2, n is 6. Yep, it is definitely less than, so it is true. Then we go to line 9 again. And this is when I need to split the screen so I can show the top half without modifying the second half. So I'm going to use this little approach here. There we go. Ah, okay, that's interesting. Let me see if I can do this. And then we can move this bar all the way down here so we can see the entire algorithm. All right, so we are now on line 9. Line 9 is comparing numbers in square brackets. Mean index is now 1, and I is 2. So we are comparing the 13 versus the 45. So in this case, mi is greater than ni is false. Okay, so I just want to double check to make sure everybody knows why on row 20, the condition is false. We are comparing element 1 to element 2. Element 1 has a value of 13. Element 2 has a value of 45. 13 is greater than 45 is false. So that means we don't go to the then statement. There's no else statement for the conditional statement. So we end up on line 12. Line 12 says, okay, let's move on to element 3. So at this point, we have already examined element 0, element 1, element 2, and we have concluded that element 1 is the smallest of those three. But do we have more elements to compare? Yep, so that's why the loop is not terminating, because we know that there are some additional elements that we have to examine. Okay, so we go back to the beginning of the loop on line 8. We ask the question, is I less than n? Yes, I is indeed less than n because I is only 3, n is 6. So we now go to line 9, and now we do the compare again. Mi is still 1, and I is now 3. So we are comparing element 1 to element 3. So now you look at element 1. This is element 3. Is 13 greater than 2? Yep. Okay, so we say this is true. We go to line 10. We update we update mean index based on I. So mean index is now 3. Then we proceed to line 12. Line 12 is just bumping up the value of I from 3 to 4. And then we go back to the beginning of the loop on line 8. And then we ask, is I still less than n? Yeah, it is. Okay, it's getting closer, but it's still less than n. Then we get to line 9. And then we ask, mi is now 3. So we're asking, is element 3 greater than element 4? So element 3 is a 2, element 4 is a 0, so 2 is greater than 0 is true. Okay, so we update on line 10, we update mean index again. So mean index is now 4, and then we proceed to line 12. I is now incrementing to 5, and now we get back to line 8. I is less than n is true. It is still true. Okay, 5 is less than 6. Okay, it is still true. So we have one last iteration to go. And then we go to line 9. Mi is now a 4, and I is now a 5. So we are comparing element 4 to element 5. So the question is 0 greater than 13? Nope. Okay, so we say this is false. So we don't go to line 10. We skip all the way to line 12. Oops, line 12. We add 1 to I goes from 5 to 6. We go back to line 8. Line 8 is asking, is I less than n? What is the answer? It is false this time, okay, because I is now 6. So now we exit the loop, we go to line 14, which in the context of this class means we are all done. We get to post. So the answer, the most important part, which is what we really were trying to figure out, which is mean index, we have an answer now. Mean index is 4. Element 4 is the smallest of the 6 items in the array. Are we good so far? Yes. So the meaning of size of is to look at whatever is in the parentheses and ask how many bytes it is taking in memory. It's a measurement of how much memory it is taking, based on whatever is inside the parentheses. So what I'm doing on line 2 is to look at the size of the entire array, how many bytes it's taking, and then I look at one item and ask how many bytes it's taking. So by doing the division, I can figure out how many items it has in the array instead of hard coding a 6. So that's up to the compiler to decide. The compiler can figure that out itself. Yep. Yep. Yes. Yep. hmm That is correct. All right. So this works. Okay. This is great. But it is only one small step of the actual selection sort algorithm. So that means I probably want to change this into a function, okay? Because the starting point is changing to, if I go back to the other tab here, you can see that, in the first um, in on the first row, we start from the very beginning. On the second row, we don't have to start with the beginning because we don't want to start with the beginning. We want to start with element one. On the third row here, we want to start with the third element. On the fourth row here, we want to start with the fourth element here. So that means in the program that we just wrote, the way okay, let me bump up the font size again, just so that it's easier to read. So that means where we start min index and also where we start I is going to change over time. Okay, we don't always want to start from 0. Sometimes, the next iteration, we want to start with 1, and then we want to start with 2, and so on. And I is really just 1 plus min index. So the first thing we do here is to say, okay, this is really just min index plus 1, because if we know that we should not be, it's not productive to compare an element with itself, but it's always okay to start with whatever is next to it. So we can change this here. So now the next task we need to do is to turn this code in main, other than the initialization, into its own function. So we want to turn it into a function to find the minimum index of an array when we can specify where to start with. Does everybody understand what I am saying, what I'm about to do? I'll say that one more time. I look at lines 5 all the way to line 14, and I say, well, this code works, okay? But I want to turn it into a function so that I can invoke the function with a different starting point of min index. Because we need min index to be a 0 for the first row of the example. We need min index to be a 1 for the second row of the example, and so on. So we are basically parameterizing the the code here so that I can encapsulate the logic in its own function. Okay. All right. So we're gonna do that. So we will say find min index. That's the name of the function. What does it need to get the job done? Well, obviously we need the array, right? So we need the array of numbers. Okay. So we this time I just call it nums. Okay. It is an array of integers. We need to know the number of items in nums. So we'll call it n. And we also want to know where to start. So the way we start is I'm going to call this mean index or starting point. Okay, we'll just call it start index like so. So that's the interface, which means these are the things that I need to know in order to find the index of the smallest item from start index all the way to the end of an array that is passed to me as nums. Does everybody understand what I just said? Should I say that one more time? Okay. Okay. So we are trying to make a function, okay, a piece of code that has a very well-defined interface to the rest of the program, which means, it knows exactly what it needs to get a job done. What is its job? Its job is to find the index of the smallest item starting from start index, okay, we give it a starting point, and all the way to the end of the array. That is its job. So it is also helpful in your other classes to kind of document what the function is supposed to do. So that we can say find min index finds the index of the smallest element of the array nums from the index of start index all the way to the end of the array, and specifies the total number of elements in nums. Okay, is that helpful? Does everybody understand the comments itself? I sure hope so. Okay, I sure hope so because that is just really spelling out what the function is supposed to do. It doesn't say how it is going to get the job done. It just says what it is supposed to do. Okay, so this is a good time to do a little segue because I want to see if AI can figure this out. Okay, remember what I said earlier in the lecture. Okay, at the very beginning, you want to kind of learn about the capability of AI, but you cannot do that without actual experimentation. So this would be a great way to experiment. Okay, so let's go ahead and try this with Gemini. Okay, so I'm going to go back to here and open a tab to Gemini. If I don't have one, I don't have one yet. That's fine. And you all have access to Gemini too. Okay, you don't need your own subscription because the Chancellor's office, the state Chancellor's office, has paid Google enough money to give you access to Gemini for the next 3 years or so. Okay, so this is a resource that is available to you, but whether you use it productively or not is up to you. Okay, so you kind of have to keep that in mind. Okay, so I'm gonna ask you the question here. I will say, I will describe exactly what the function is supposed to do. So I will say write a C++ function called find mean index that uh, does the following. Okay, so this is important because even if you do not do the coding and you just describe what the function is supposed to do, you still need to know how to describe it. Okay, so this is how I'm going to describe it. Okay, so the first thing you need to do is to specify what value it is supposed to return, what it is given with. Okay, so now you can start with what it is given with. So we can say the function is given with the following. So we'll say it has nums is an array of integers, and then we have n is the number of elements in nums. Start index is the index of the first element to examine. And then you also have to specify what it is supposed to return, okay, the return value. So now you have to specify the function is to return the index of the smallest element, starting with start index all the way, okay, all the way to the end of the array nums. Okay, so the function is to return the index of the smallest element. Okay, I suppose I can say in nums, starting with start index all the way to the end. Okay, so I think I have properly specified the specification of the function. I told the AI what the function is supposed to do, not how to get it done. Okay, are we doing okay so far with the prompt to AI? Okay, so I think in the future, okay, by the time you graduate from a 4-year university, for easier stuff, you can do it this way. But for more complicated things, you still have to figure it out yourself. Okay. So now we'll press the enter key and see what happens. All right. Well, it uses the for loop, okay? So I don't want it to use a for loop. So I can now use the prompt here to say, okay, do not use a for loop because we haven't talked about a for loop in this class. So I can say uh, only use while and do while, change the for loop to one of the other loops. Okay, because in this class, we haven't really talked about the for loop. So we're going to change it. All right. Does that look familiar to you? Okay, which part looks familiar to you? Well, first of all, on line 11, it, it initializes mean index to start index, which is not efficient. There's no need to compare an element with itself to find out whether it is less than itself. It cannot be less than itself, right? So you can identify that, okay? You can say, uh, but this algorithm is going to compare the first element to itself, and this is inefficient. Go ahead. Oh, it does. Yes. Okay, very good. Thank you. That's a good point here. All right. But does the rest look familiar to you? Okay, the first line, I mean the first portion here is error checking, but the rest of this code, let me highlight which portion I want you to focus on. It would be from here to about here. Does that part look familiar to you? Yes. So that means our main is already pretty much done. It got most of it done. I just need to kind of decorate the algorithm or decorate the function with a few other items, like including the return the mean index later on, and then it's almost done. Okay. So this is what AI can do already. Okay. This is actually a child's play from the AI's perspective. Okay, it can actually write algorithms that are far more complex than this. Okay, so the question that you have to ask yourself is, what is the whole point of taking classes? What is the whole point of figuring out the algorithms by yourself at this point of time? Okay, I have the answer to that question, but I want you guys to think about it. All right, so I'm going to go back here. Okay, I will do all the editing by hand. Okay, so I am going to do some copying. So I'm going to say line 12 to line 21. I want to move all of those to here. Okay, I like VI because it let me do something like this. Okay, so now I can say mean index is going to start index, and I is mean index plus 1, and I just have to return min index at the very end. Is that okay? So I just turned a piece of code that was not in its own function into a much more flexible function. with a different with a parameterized starting point, which is called start index. Will be good. All right. So I have my solution. I suspect the solution is the same as the AI solution. So what I'll do is now I can ask the AI to compare this with its own solution. Okay, you can actually do stuff like that. So now I go like, okay, put in the semicolon here, and I need to put this all into the clipboard. So it's line 6 to line 18. We want to write it to the pipe called xclip dash cell clip here. Okay, and then I switch back to the algorithm. Okay, so now I say, okay, I have my own implementation of this function as follows. So when you want to put in a block of code and you want to make sure that the AI knows where your code starts and where it ends, we put in backticks to start the block of code, and you can specify what programming language we're using. So C is fine, okay? C includes C++. And then I just do a paste here, and then do another 3 backticks here to mark the end of the block. And now I'm asking the AI to compare my implementation with its implementation. It should be the same, they're almost identical. The only difference is the comparison. I flipped the comparison the other way, but I'm using a greater than, so it should work too. Yep. On line 21, yeah, I plus plus is I gets I plus one. Essentially the same thing, but I choose not to introduce too many ways of doing the same thing. So that's why I didn't talk about auto increment. It's called auto increment. Hmm. All right. So let's see. It looks like you have a solid C style implementation using a while loop. I noticed a small issue in your code that would prevent it from compiling. You use numbers inside the loop, but the function, oh, okay. So it does even the job of a compiler. Okay, I will show you what the problem is. Because the name of the parameter is nums over here, but I'm using numbers as a to reference the array. So that's actually pretty impressive. Okay, the AI does the job of both verifying the logic of the code and also quote unquote doing the compiling as well. It spots all kinds of problems. Are we doing okay so far with this example of using AI? Now, did I need the AI to get this to work? No, I came up with the algorithm to begin with. Okay, I asked the AI to write the algorithm after I got it done in the first place. So that is something that you can potentially do with your homework assignment is to get it working with your own code first. Do not use the AI to help. Okay, after you're done, after you turn in your homework, then you ask the AI to come up with a solution and compare your solution to the AI's solution and see if they are equivalent or whether one is better than the other one, or so you can at least do a comparison. Okay, so that's also a use of AI, is not to have it to generate the solution to your homework assignment. You do your own homework assignment, then you use AI to compare its solution to yours so that you might learn something from the AI's own solution. Because if you are doing something that is incorrect, it will spot it and tell you. If you're doing something that is inefficient, it will spot it and tell you too. Okay. You can even ask it. Okay. So let me go back here and I ask um, in your solution on line what is it? 14, okay? Why did you add one to start index? Question mark. Okay, so let me point to the screen here. It doesn't have to, this plus one is optional, okay? It is not needed. Without the plus one, the algorithm would still be correct. It won't find the wrong answer, but it is going to waste one loop because you would end up comparing an element of the array with itself in the very first iteration. So I know the answer already. I'm just testing whether the AI can explain that. Okay. Press the enter key. All right, so I think it has the answer already. Okay, let's scroll and find out what it says. I added one to start index because we already assumed the element at start index is the minimum on line 11. Therefore, we don't need to compare the element against itself. Okay, that's basically the same thing that I said. We start the loop at start index plus 1 to immediately begin comparing our current minimum against the next number in the list. So that's essentially the same explanation that I was explaining earlier. Okay, so if you're curious, you can also say, you can ask if we did not add one on line 14, is the algorithm incorrect? Okay, the answer is no. Okay, the algorithm remains to be correct, but it is not as efficient. Okay, that would be the answer. But I want to test the AI. I want to test its capability. So we will take a look at the answer from the AI, from Gemini, because I think it is important for all of you to understand. So no, the algorithm would not be incorrect, which means it is still correct. If you did not add one in the selected code in the canvas, which is this line here, if you initialize I equals to start index, the loop will simply run one extra time or one extra iteration through the loop. So it is a very, in other words, Gemini knows not only, it's not just remembering known solutions up to this point of time and just regurgitate, it actually understands the logic of the code. Okay. So what do you feel about this? Who is your competition in about 4 years of time? So you can see it in different ways. Okay, you can look at Gemini as an assistant. Okay, so what you need to do is you need to do everything that your assistant is able to do, then also something more. Okay, which means the minimum of what you need to be able to do in 4 years before you graduate and try to look for a job is to be able to do everything that your homework assignment asks you to do by hand without the use of AI. But at the same time, you also need to know how to use AI to do the same thing. So that simply is a matter of ordering. Do your own work first, turn it in, then use AI to evaluate the work that you have turned in. That would be the quickest and easiest way to incorporate one, learning how to do things by yourself without using AI, and two, using AI and have the experience of, oh, okay, I can see that AI can debug my program. It can make it more efficient. It can tell me what I'm doing wrong with my own code. But don't do it before you turn in your own submission. Okay, so that's my recommendation. Obviously, you guys can make your own choices, and you will have many choices to make in the next 3 or 4 years before you graduate with a bachelor's degree in computer science. So that would be the end of today's lecture. I hope this is a little bit useful. Maybe, maybe not. All right. I'll see some of you on next Monday, which is going to be the day that we talk about the practice exam. And then on next Wednesday is our last lecture. All right. Time to turn off the recorder.